For our last lesson in this unit, we're going to take what we've learned from inequalities and what we've learned from systems of equations, and we're going to combine those two concepts together. You may recall that a solution to a system of equations is generally a point at which they intersect. You also may remember that from graphing an inequality that we created a shaded region for the single inequality. So in a system of linear inequalities, what we're going to really be dealing with is two inequalities at once, and the solution is going to actually be the shaded part that is for both inequalities. So the place where we're going to see two sets of shaded regions at the same time. So we're just going to take a quick look at an example here. At example number 1, now you can see that we have a system of inequalities here that are already in slope-intercept form. This is very helpful as far as graphing our lines are concerned and then testing a point. What you'll notice from the solution here is that when we graph y is greater than negative 3x minus 1, we get this kind of this red shaded region to the right of the line. And then when we graph y is less than x plus 2, we get the blue shaded region underneath the line. That purplish area that is combined with the two shaded regions is what is the technical solution to this system of inequalities. Now, again, if you remember from graphing inequalities, we don't write this out as a solution set. Basically, the shaded region is our solution set, and so that is primarily all that you're going to do. So you already have the skills necessary to complete this lesson. If you haven't worked sample problem 1 part A and B, I'm going to ask you to go ahead and stop the video at this time and try to work these two first, and then come back and take a look at the given solution. Okay, I'm going to start off with the first equation in our inequality in part A. Now what I'm going to do is I'm going to start by changing this to an equal sign and converting it to slope-intercept form that way. Basically, all I want to be able to do is graph the same exact line. I'll worry about the inequality after I get the line on the graph, so I'll go ahead and do that now. Notice that we have a negative 3/2 as a y-intercept. Just guesstimate that as best you can as you're doing your counting here. Now that I've got the line down here, first of all, I need to check the inequality. When the inequality shows me that it is less than or equal to, so I know it's a solid line. Now what I need to do, and this is an important part of this process if you remember from graphing inequalities before, I converted to slope-intercept form. But I want to test my point back in the original inequality. So I'm going to test the point 0, 0 in my original inequality. And I get 0 is less than or equal to 3, which is a true statement, which means that 0, 0 will be part of my shaded region here. Now I personally like to use the highlighter functions on the computer, because whenever you use the highlighter functions, they give you a nice blended color so you can see the actual solution set. So now I'm going to take the second equation. I'm just going to turn it into an equation for graphing purposes. So this is going to be y equals 3x minus 4. And so I'm just going to graph y equals 3x minus 4. Now before I go ahead and draw this line, notice that the inequality is greater than, but not equal to. So I have to remember that this is a dashed. Then I'm going to test my point 0, 0 back in the original inequality again. So now you can see that we have a true statement. 0, 0 is part of the shaded region, so I'm now going to use a different color to graph that shaded region. So I'm going to use the blue, and you can see by using the blue, when it mixes with the yellow, it gives me this green part, which then shows me visually where the solution to this system of inequalities is. So that's a quick example of solving a system of inequalities. The solution is the green area, all of the points in the green area, and I'll just quickly go through part B as well. Okay, so I've graphed the first equation and inequality here. Now I'm going to do the second one. And you can see I'm just quick sketching, so some of my points may be just a smidge off here, but now we need to shade for the second one. This is also true for the point 0, 0. And so you can now see the green area is the solution to this. Okay, so hopefully you did well on that, and remember, you can always check both of these on your calculator as well. For our final example, the system of inequalities that we have is going to give us three equations. This is going to create three separate shaded areas. Now, in a lot of cases, what ends up happening is you end up getting the whole graph shaded, but your solution in this case is where all three shaded parts convene together. So if you look at the example number 2, it asks us to graph all x values greater than 0. So it's going to be everything on this part. Then it wants us to graph everything y greater than or equal to 0, and so that ends up being all the y parts. Now you can see here where the green is starting to kind of take shape. However, we have one more part here that asks us to graph 4x plus 3y is less than or equal to 24. So this ends up being graphed on this side of that particular line. And what you can see here is, even though it's very colorful all over the grid, we've done the entire grid, we kind of end up with this black triangle in the middle. And so this black triangle is where all three shaded parts converge. So that black triangle actually ends up being the solution for the whole thing. So if I end up erasing that, you can see from the graph from the sample problem, they've only decided to graph the solution, which is just the shaded region of both parts. And I think if you do enough Math Excel problems, you'll notice that they don't want you to shade everything. They just want you to shade the solutions, which is the ones that satisfy both or all three inequalities. So let's just take that and move down to this example. So go ahead and take a little time to work sample problem number 2, part A and part B, and then come back and take a look at the solutions. Okay, so I want to mark all x values less than 0. And of course, if you want to graph the line, if you want to go ahead and graph the axis, you're more than welcome to. It's probably the appropriate thing to do. Then I want all y values greater than 0. Again, it's equal to, so if I graph the line, and then all y values greater than 0. And then lastly, I need to graph this line. So now I want to graph the line y equals x plus 2. So I'm going to go up 2, and then obviously a slope of 1, and it's equal to as well, so it's going to give me a line that looks somewhat like that. Now, if I want to test this point, I go back and I test it in the original equation. So 0 is greater than or equal to -2, so that means that this will 0, 0 would be part of the shaded region, and so we get this following part of the graph. Now, what you can see here is we got a very colorful graph, but again, the black part, the black triangle in the middle, and I'll just try to color that in black, and if I erase everything around it, that pretty much gives me my solutions. That's the triangle with the shaded region of all three graphs. So that's kind of what we're trying to get at here with this particular type of problem. Alright, let's look at one more. Instead of using the axis, we have something a little bit different. So we have x is greater than or equal to 1. Then I have y is greater than or equal to 2. And then lastly, I have y is less than or equal to 5 minus x. So I could also write this as -x plus 5. That would be a little easier to see. So I'm going to go up to plus 5 and down 1 over 1. And so it's equal to, so that's going to give me that. And of course, it's less than that, so everything here. And again, we get the situation where everything's colored in. And you can see the black portion, that's a triangle here in the middle of this. And so that tells me my solutions. And I didn't quite get it all, but you can tell through the shaded region that's what it was. Now, when you're graphing shaded parts on a paper test, the best thing to do is to lightly shade every single part, and then where you see the overlap, come in and shade it quite a bit darker on the back end. So don't go in there full force shading really dark right off the bat, or you won't be able to see the shaded region as well. And that's just a little different than working on the computer. All right, hope this helped.